So good morning and good afternoon, everyone. Thank you for tuning in to today's webinar. So in today's webinar, I'll be covering the most essential properties of material testings required for CA analysis. Okay. So very often when we look at the injection moldings, we see these big machines with the nozzle, the screws, and the injection units, and also the mold units. So in order for a successful mold trial to come out, there are usually a couple of factors, and such as the mold design, the part design, and in the injection molding process, we usually try to separate whether the defect is related to a mold design or part design, or whether it is material related. Luckily, what we can do is that we can use CAE to help us do that. To separate the issues that's related to part design issues or the mold design issues. But what's very often neglected in the CA analysis is the material properties of the materials that you use. So that's often the what we call the black box behind the CA analysis. Because very often people would just assume that, okay, if it's the same grades of materials, such as polypropylene or polyethylene, regardless of their compositions, they should behave similarly. But that's often not the case. Even though sometimes you might look at the data sheet and determine, okay, you have similar MI values, so the materials should behave the same or similarly. But bear in mind, MI values are taken or measured under very the different sets of conditions than your injection molding conditions. So those values are useful information for molders for mold trials. But when we are actually doing the CAE analysis, we need the broad spectrum of material properties, such as the complete viscosity curve or the complete PVT diagrams, and also your heat capacity and thermal conductivities. So that's what we call key factors to a successful molding for successful molding trials.